Alrighty, so the math dealer here, and today we're going to use logarithms to find derivatives. Okay, so that's what we call logarithmic differentiation. So for starters, let's talk about some properties of logarithms. Now this property box, all these little properties you learned way back when in Algebra 2. If you do not remember any of these things, you might want to go watch my other videos on, logarithm properties. I know, right? Too fun. Okay, so just kind of quick review. When you have a product, you can actually break it down to a sum. If you got a quotient, you can break it down to a difference. And whenever you have a power, the power can flip out in front. All right, then we also talk about the root one, but just remember, a root is also a power, and the power is going to be 1 over that number, and it can fly out front. All right, so with all that in mind, and I really know I went fast, but like I said, if you don't remember any of that stuff, just take a trip down the YouTube rabbit hole, and you'll see my video on logarithm laws. Okay, so here we go. So let's say your mission in life is to find dy dx. Oh, you know what? I'm going to try to be neat. We'll see about this. Okay. So for starters, before I even begin the problem, like before I even go to find a derivative, I'm actually just going to use my properties that I listed up here to work it out. So think about it this way. If you have a quotient, remember, if you have a quotient, which I do right here, it can turn into a difference. So I'm going to write minus natural log, and I'm going to write square root of 7 minus x. And like I said, I'm really going to try to be neat. We'll see what that which works. Okay. So now the power, of course, is going to come down in front. Now, look, I am not doing a derivative yet. And I think that's what messes people up the most is that they want to think, oh, I'm supposed to change this to a 4. But you're not. You're just using a property of powers here. Okay. That's what you're using here. It's a property of powers. Okay. Now, remember, if you have a square root, that's a 1/2 power. And that's going to flip out in front. So again, these are just properties. Notice it still says y over here. It doesn't say dy dx. Now I'm going to go find the derivative. So the derivative of y is dy dx. Of course, recall the derivative of the natural log of anything of u is 1 over u du dx. So let's not forget that guy. Okay. So it becomes the 5. He's just chilling. And it becomes 1 over x squared plus 8. And then, of course, times the derivative of the inside, which is 2x. Minus, slip over here, 1/2 is just trickling down here. And then it's 1 over the u. The u is 7 minus x. But don't forget about the du dx, because that does have to pop out. And the derivative of negative x, 7 minus x, is just negative 1. So your answer is this. It's 10x over x squared plus 8 minus, and then another minus makes a plus, 1 over 2 times 7 minus x. Okay? That's my dy dx. Like, that is my derivative. Now, some people go, oh, I know how to do this problem. I'm going to go ahead and do a quotient rule and do all this other stuff in here. But no, that's what the whole point of logarithm differentiation is. It's to actually make the problem easier. Okay? A little bit easier to do. All right, now look at this problem. Okay? This one up here, it doesn't have a logarithm in it, but that's the beauty of a logarithm. Like, you can bring it in to both sides of the function, okay? So I can actually say, well, I start with y equals the square root of x times x plus 14. Well, if I bring in the natural log to both sides, now I have the natural log of y equals the natural log of x times x plus 14, and the whole thing's been square rooted, okay? Now, let's use some properties. The natural log of y equals 1/2 flips down in front, natural log of x times x plus 14. And you could distribute that, but you really don't have to, because all I'm doing is using my properties. Now remember, the natural log of any two things that are being multiplied together becomes the sum of those two things. And that's that property that deals with the natural log of AB is the natural log of A plus the natural log of B. I hope that made sense. Now, here we go. Find the derivative. Well, derivative of the natural log of y is 1 over y, dy dx. And then over here, the 1/2, he's just chilling, right? Derivative of the natural log of x is 1 over x times 1, but why would I write 1? And then again, the derivative of x, natural log of x plus 14 is 1 over x plus 14 times the derivative of that, which is just 1. Now, remember, your whole job here was to find dy dx. Like, that was your mission. So to get the y out of here, I got to multiply both sides by y. And this is honestly what people, some students get like all confused about. And they're like, wait a minute, where's all this coming from? Remember, I just multiplied through by the y because it was sitting on the other side. Now, real quick, I'm going to say, sorry about that, little craziness over here. Okay. So now let's not forget that this value up here, this function is my y. So when I go back, I say, okay, well, y was the square root of x times x plus 14. Okay, it's over 2, so I can actually just put 2 over there. And then it's 1 over x plus 1 over x plus 14. And that's it. Like that, as silly as that looks, that's your answer. Okay, there's your answer. You really don't have to do much more than that. Some people go ahead and find a common denominator in here, but this is not algebra. All right, this is calculus. So you can actually leave it like that. All right, last but not least, okay? Like I said, I'm going to be super neat. We'll see. All right, so here we have a funky old problem. Okay, so what you want to do first is bring in the natural log to both sides. So the natural log of y equals the natural log of this entire expression. So I'm just writing the entire expression out. And of course, if you have to, go ahead and pause the video and go back if you need to. I'm okay with that. It's not like I would know. Okay, and then here we go. Now let's go and just use our properties. Notice I'm not taking a derivative yet. I'm just using the properties to break this down. So remember, if you have a product, you have a sum. And if you have a quotient, you have a minus. I hope that makes sense. If it doesn't, you might want to go back and talk to your pre-cal teacher. So here we are. Now, find the derivative, right? Well, actually, I actually can do something. I can take that 1/3 and slide it out front. Right? Just like I could take, actually, you know what I'll do? Here we go. I'm going to write another step. I told you I was going to try to be neat, and then there I went to try to be sloppy. Ugh, how dare I? Okay, so now I have x squared plus 4, 1/3, x plus 7, and yeah, this is all grouped together. We know that. Okay, now let's do a derivative. Let's do a derivative in green for whatever reason. Okay, so the derivative of the natural log of y is 1 over y, dy dx. Derivative of the natural log of x is just 1 over x times 1. Derivative of this guy, remember the 1/2's just chilling. It's 1 over x squared plus 4, but don't forget the derivative of x squared plus 4. Some of my students have forgotten that. Not you all, of course. So 1 over x plus 7, and then derivative of x plus 7 is 1. So now I'm just going to clean this up just a little bit more, okay? And what I mean by that is I'm going to send my y to the other side, and I have all of this expression, 1 over x. 2 can definitely go into that. So I have x over x squared plus 4. And then I have minus, and remember, these are being multiplied. So 1 over 3 times x plus 7. And then, last but not least, we know what y equals, right? Remember, y was what was way up top here. Okay, remember this guy up here? That's what my y was. So here, let me just, I wonder if I can just move it. Nope, can't do that. Anyway, so that y is, what's it say? X square root of x squared plus 4 and x plus 7 to the 1/3 power. So that guy I'm going to slip on down here. Okay, so this is how I cheat a little bit. So I go equals x, right? Square root of x squared plus 4 over x plus 7 to the 1/3 power. And then, of course, that expression is all the same. And as I said, you can leave it like that. Very seldom do teachers make you simplify that. But if they do, then that's just finding common denominators, right? That's nothing but a heartbeat. Okay, I know this was a little rambling, but I really hope this was helpful. All right, this is the Math Dealer signing out. See ya.